Okay, so if you remember, our aim was how do we prove the properties of a parallelogram? So if you remember, the properties of a parallelogram are nothing more than, well, the definition of a parallelogram is nothing more than a quadrilateral with both pairs of opposite sides parallel. And in a previous video, we discovered that each of these properties is actually a theorem, and we proved the first theorem, namely that both pairs of opposite sides are congruent. We proved that, and we proved that right over here, and everyone took that down. Now the question is, how do we know that both pairs of opposite angles are congruent? Both pairs of opposite angles are congruent. Our approach is going to be exactly the same. Let's take a look at this. So, here's one thing to remember. To prove a property of a parallelogram, you can use the definition, which we did before. You can also use other properties. In other words, you can use a property of a parallelogram to prove another property of a parallelogram. And that's exactly what we're going to do here. Let's see what it says. It says, given parallelogram ABCD. Parallelogram ABCD. So if this is a parallelogram, what is the definition? Definition says that both pairs of opposite sides are parallel. So let's actually mark that down. So both pairs of opposite sides are parallel. So AB is parallel to DC, and DA is parallel to CB. Very nice. It says, prove that angle B is congruent to angle D. Prove that opposite angles of a parallelogram are congruent. They could have just as easily asked us to prove that angle A is congruent to angle C. They asked us to prove that angle B is congruent to angle D. It makes no difference. They can ask us either thing. Okay, so let's understand what we're going to do. We're going to, first of all, construct a diagonal. In other words, we're going to draw a diagonal. We're going to draw a diagonal that goes from D to B. Okay, we're going to draw a diagonal that goes from D to B. And we're going to use triangle congruence to prove that angle B is congruent to angle D. Actually, you know what we're going to do? Let's remove this, and let's draw a diagonal from A to C. Let's draw a diagonal from A to C. There we go, A to C. Think about what we're trying to do. We're trying to prove that this angle here, angle D, is congruent to this angle here, angle B. So what I'd like to do is prove that these two triangles, namely triangle ADC, triangle 1, is congruent to angle CBA, triangle 2. That's what I'd like to prove. Okay, so I'm going to draw a diagonal, AC. What is the property that I know about a parallelogram? Well, of course, the definition is both pairs of opposite sides are parallel, which I noted here. But also, if you remember, we already proved that both pairs of opposite sides are congruent, which means I can use this property here to prove this theorem here. Right? So one of the things I know is that not only is AD and BC parallel, not only are they parallel, they are also congruent to each other. And not only are AB and DC parallel, they are congruent to each other. And of course I know that AC is a line that is shared by both triangles 1 and 2. Therefore these two triangles are congruent by none other than side, side, side. So we know what our marching orders are. If these two triangles are congruent, what do I know about all their corresponding parts? Well, I know that all the corresponding parts are also congruent. In other words, angle D is congruent to angle B. And that's exactly what we're being asked to prove. So let's put this down on paper. So we have a statement, we have a reason, and of course this belongs in your notes. Make sure you take this down in your notes. You need to know it. You can be tested on it. First order of business is parallelogram ABCD. I'm going to draw the diagram. This means parallelogram. Parallelogram ABCD. Reason for that? Well, it is given. Well, what do I know? Because the ABCD is a parallelogram. I know that opposite sides are congruent. Remember, I want to use a property that I've just proven. I want to use a property of a parallelogram to prove another property or theorem of a parallelogram. So I can say that line segment AD is congruent to line segment BC. I can also say that line segment AB is congruent to line segment DC. Why is that? That is a property of a parallelogram. That's supposed to look like a parallelogram. Okay, so that's statement 1, that's statement 2. Well, look, if I'm going to use triangle congruence, right, I'm going to use triangle congruence, let's keep track of what I have so far. Well, I have 2 sides. Very nice, but unfortunately, side is not a proof of congruence. Actually, that's a good thing. Okay, what else do I know? Well, statement number 3 would say that AC is equal to CA. Line segment AC is congruent to line segment CA. Reason for that, the reflexive property. You can say reflexive property of congruence, reflexive property all by itself is perfectly fine. Well, look what I've got. I've got another side. So what can I say? Well, I can say the two triangles, namely triangle ABC, I can say statement number 4, triangle ABC is congruent to triangle, remember, ABC. If I'm starting off with this, A, then B, then C, what corresponds to A in triangle 2? Well, C in triangle 1. So I can say that triangle ABC is congruent to triangle CDA. Triangle ABC is congruent to triangle CDA. Why? Well, because of the SSS triangle congruence postulate. Well, what is the fifth and final statement? Exactly what I'm being asked to prove. If two triangles are congruent, all their corresponding parts are congruent. So that would mean that what? That would mean that angle B is congruent to angle D. The reason for that is CPCTC. Corresponding parts of congruent triangles are congruent. So that is the proof for the second property. I hope this is down in your notes. If it's not, put your player on pause and make sure you copy it down together with the diagram.